It is now 5 days later and still no eruption or magma run has occurred. So, why exactly has a volcanic eruption not occurred yet, and when might the next eruption occur? This video will attempt to answer these two questions, and discuss what might happen next. For context, the Reykjanes Volcano covers this shaded area of Iceland and represents what could be described as the simplest type of volcano in existence. It is essentially an emergent portion of a mid-ocean ridge above sea level where the Reykjanes volcano crust spreads apart, allowing for magma to occasionally intrude into it and erupt via a series of fissures. Sometimes these fissures leave fairly sizable gaps in the ground, but each side doesn't exactly represent a separate tectonic plate. Rather, a several kilometer-wide area is experiencing rifting, which sort of serves like a middle ground between what are definably the North American and Eurasian tectonic plates. Since October 21 of 2023, 5 magma run events have occurred when molten rock pooled to such a volume that it cracked what was the path of least resistance towards the east before flowing at depth while simultaneously rising along another weak spot which trends northeast to southwest. Each of these events has produced a declining number of earthquakes when compared to the prior event, and the March 2 failed intrusion was no different. However, despite only involving 1.3 million cubic meters of molten rock, or about 15% of the present magma chamber, the intrusion produced far more earthquakes than it should have considering its small size. Theory number 1. One possibility is that there is another somewhat hidden and hard to measure factor other than simply the volume of magma present which determines when rock will fracture. What I am referring to is one of the main things that rapidly propels magma upwards: gas, albeit primarily carbon dioxide. My suggestion is that while only 15% of the magma was involved in the failed intrusion, that a disproportionately high amount of less dense gas, let's just say for an example 60%, was involved. Since both high gas and a fairly sizable volume of magma need to be reached, it will likely take longer for the next magma run event to occur. One indication that this hypothesis could be correct is if during the next magma run that molten rock migrates upwards in the crust more slowly than it did beforehand. Theory number 2. Possibility 2 is that for an unknown reason, perhaps due to a progressively thicker seal forming with each intrusion, that a larger volume of molten rock is needed to build before it can once again migrate to the northeast. Theory number 3. Possibility 3 revolves around a scientist's incorrectly identifying a pattern where one does not exist, with the assertions being based on a very small sample size. The apparent pattern of decreasing time each cycle takes has only been accurate during the last 4 cycles, which statistically has a 6% chance of simply being due to random variation. In other words, the amount of magma needed to generate a magma run could vary between 8.6 and 19 million cubic meters, perhaps a bit further on each end, meaning we may have to wait another 12 to 17 days for an eruption. Theory number 4. The pre-existing magma pathway could also be now effectively closed shut, meaning magma now has to find a different path of least resistance to the surface. What direction this could be is unknown, but it could even be upwards. I hope you can appreciate the complexity and unknowns of this situation in what should be one of the world's simplest volcanoes to model.